Hello and welcome to the Day 8 video for Upward Bound Advanced Math Cryptology. Today, I do apologize that I won't be able to be there, but hopefully with the work that you have to do along with this video, hopefully we can make today just what I wanted it to be, and that is really just a review of everything that we've covered so far. We've gone over a lot of different ciphers and really kind of struggled through some other ones kind of made sense, but at the end of the day what I really want you to do is to be able to be pretty efficient at every one of the ciphers that we've talked about. So I do want to take a little bit of time today and get a quick review over how to work with those ciphers and make sense of them. So if you're ready, let's go ahead and get started on this. Now, through this video, I am going to ask you to pause the video several times. I kind of went back and forth, and I actually recorded every one of the different lessons individually to see what that looked like. And it just seems like it would be a little bit taxing to leave one of the videos, come back to the next video, leave that video, go to the next one. It seemed a little mundane or monotonous, if you will. That it just seemed like it would be a pain to do as a student. That's what I was thinking of, is in the student mindset, it felt like it would be difficult to do that. So I decided, let's go ahead and make it one full video, and I'll just have you pause it over and over again as we go. So to get started, we're talking about general substitution ciphers, and the way we kind of dealt with this, we didn't really do it in the way that I have presented in class, but we dealt with the one kind of at the bottom there, the pigpen cipher. We dealt with that on day one. General substitution ciphers are just ciphers that say there is no rhyme or reason to why I have one letter matched up with another. It just says this is the cipher that I'm using. So what you're going to do, what I want you to do, is to try numbers 1 and 2 using this general substitution cipher strip at the top to encrypt and decrypt. And then for number 3, we are using the pigpen cipher, where these symbols at the bottom show a great example of an encrypted message based on the pigpen cipher. So you can encrypt Bernhardt with these letters, and then decrypt this to come up with a different message. Okay? So go ahead and pause the video now. Try this encryption and decryption just to get you started. The encryption of Albert starts with A, which A becomes D. I know that may look like something else, but it is the letter D. So again, go and pause the video here. Try these 3 problems. When you're done with these 3, push play again and get back to where we are. Hopefully you had a chance to do that. Now that you've had a chance to do those problems, let's go ahead and see how you did. Albert becomes DKXZTF. And I went with Albert Einstein, so the decryption becomes Einstein. My theme today was famous mathematicians. I thought I'd have a little fun with that. And Albert Einstein was one of those. So not that it didn't allow for some kind of, what I want to say, some premonitions maybe as you're going through some of the encryptions and decryptions. But yeah, that is what it is. Down below in the pigpen cipher, Bernhardt becomes this. There's really no way for me to say it. There is a dot in that one, and kind of how you choose to put the dots is totally up to you. Just make it obvious that it follows from that substitution cipher. And the decryption ended up being Riemann. Bernhard Riemann was a famous mathematician who did a lot of work in calculus, and if you go on to calculus, you'll probably do some work with what we call Riemann sums. So that's where that comes from. Now that you're done with those, let's go ahead and look at the next one. The next thing we talked about were Caesar ciphers. And see, for the Caesar ciphers, the strict Caesar cipher is just shifting your ciphertext over 3 spaces. I'm going to go ahead and have you do it with a shift of 10, and I want you to fill out the cipher strip. I think that these make life a little bit easier than the wheel that we have. You can use the wheel if you want to, but there's always confusion of, did I rotate it the right way, and which one is my plain text, which one is my ciphertext. So to get you going the right way, I like to use the cipher strip and for you to fill it in. What it means is that my ciphertext A is going to move over 10 spaces. Okay, so move that over 10 spaces, write your new alphabet, and then wrap back around until you get back to the A. You'll have 9 letters that you're gonna be putting under A through the 10th letter. I'm not gonna spoil that surprise. Use that cipher strip just as we did before on numbers 4 and 5. And then down below, we're talking about ciphers with numbers. I'm going to talk through these before I give you a chance to pause and try it. Of course, you could do that if you wanted to, but we're going to go ahead and look at these. So ciphers with numbers are slightly different, and I want you to think about how they're different from Caesar ciphers. I'm telling you to add 15 to every one of the predetermined A through Z numbers, 0 through 25. I want you to add 15 to each one of those to come up with our new sort of shifted alphabet. Okay, then use that for A and B down below. You're going to encrypt Euclid, and so what I would look to do is maybe below Euclid put the plain text numbers, and then below that put the shifted numbers, the added numbers. Okay, and same thing backwards here. Maybe put the plain text numbers here, and then the plain text itself in the top row to come up with an actual message. Go ahead and pause the video now and try those kind of 4, kind of 6 problems, however you want to look at it. But go ahead and pause the video now. Hopefully you had a chance to do that. If you didn't, you better, because I'm going to spoil the answers right now. So a shift of 10, a Caesar shift of 10, brings the ciphertext A under the plaintext K. So in a sense, that's moving my ciphertext to the right. Okay. Now with the encryption and decryption, Isaac becomes YIQQS, and Newton is the deciphered or unciphered version of DUMJED. Okay, so we're going with Isaac Newton on that one. Now, the trick here is that when we start dealing with numbers, this, even though I have it grouped with Caesar ciphers, it's really not a Caesar cipher at all. The only thing that makes it somewhat similar is that the numbers, meaning eventually the letters, are still in order and they've just been shifted, but this actually looks like a Caesar cipher of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Really just looks like a Caesar shift of 11 because my pen's lagging out, sorry. Oh, don't do it, don't do it. It's not going to go where I want it to. Okay, I'll deal without it. Yeah, see what I mean? Here we go, it's catching up. I wrote the letter A in there somewhere, but it didn't really like it. So it turns into adding 15 to all the plain text numbers essentially turns into a Caesar shift of 11, this being the 11th number. So it is drastically different, but there's enough similarities that it actually ends up working out. Euclid gets encrypted with a plus 15 shift of 19, 9, 17, 0, 23, 18, which you could give those ciphertext numbers or letters if you wanted to. I wasn't looking for that, but that's okay. This encryption here ends up returning us back to Archimedes, which is another famous mathematician. Moving on, kind of the next thing we talked about were the keyword ciphers. Now, if you Google keyword ciphers, you'll actually typically get something a little less involved than what we've done. I only know this by doing it myself. I Googled it trying to get some different problems that I could just pick out and go ahead and use, but it's actually not that easy, sadly. If you Google it and you find keyword ciphers, they typically won't come with a key letter. What they'll do is they'll just put your keyword at the start and then the rest of the alphabet. The way we learned it is the way that I want us to progress, and that is to put the word math starting at letter K. And I am kind of giving this away, but that's all right. There are still some other things to keep track of. And then after the word math, start with the rest of the unused alphabet. Okay. Use that cipher strip to encrypt Pierre and decrypt SU space VUETPG. That will totally make sense to some people, probably more French than American or English. Mainly talking that is a French name that you're going to get. So, but down below on the last one, it's another keyword cipher. It is Pythagoras as the keyword. Now there is a trick with Pythagoras using that as a keyword in this cipher, but it does start at letter G and decrypt this longer message. Not looking for us to crack any encryptions. I give you how to cipher that. So go ahead and try to figure that out. Sorry, I just got something. Pause the video now and do those 3 problems. Hopefully you had a chance, excuse me, hopefully you had a chance to get that done. And if you didn't, I'm going to spoil it now. So in a keyword cipher, remember we get the keyword starting at the key letter. So I have math written in its entirety. And essentially there, or I guess more importantly there, because math doesn't have any repeated letters, I do write the entire word math. Then from there, I skip the letters that I've used. So notice that I don't start with A, I start with B. I also skip letters like H. I skip M. I skip T. So all those letters got skipped because they are used in the word math. And then I write the rest of the alphabet. Pierre gets encrypted as CYUEEU, and the decryption ends up being Fermat, or de Fermat. The mathematician's name is Pierre de Fermat. He had a lot of theorems that were crucial in calculus and beyond. The one at the bottom was a little bit trickier. I found the cipher strip itself to be a handful. First, because Pythagoras actually skips the second A. The word Pythagoras, starting at the letter G, skips the second A because we've already used A. Now, not ironically, but even though we do have to skip a letter, we actually only skip one letter, and that ends up being a pretty long keyword. And it actually, I had a hard time making the cipher strip there. I ended up doubling up. I think I first doubled up the P, and then I doubled up R. I had a hard time, but work your way through it, get which letters you have to skip, and then the decryption becomes in a right triangle. The sum of the squares of the legs is equal to the square of the hypotenuse. That's Pythagorean's theorem in words, so I thought it was only fitting to go with Pythagoras. Okay, the last one that we talked about most recently, not last time we met, but The last cipher that we talked about were called Vigenere ciphers. And for this, we used that square, and I'm going to kind of shortcut that square just a little bit to help us understand how to encrypt and decrypt with that here. So the first thing, and not to give everything away, but the first thing to do when dealing with a Vigenere cipher is to write your keyword above your plain text letters or your ciphertext letters, and just repeat it. Repeat it until you're done with your word. If that means, like in this one, that you don't write an entire second word math, that's okay. End where you end. And now to do this, it's essentially a Caesar cipher, but 4 of them. Okay. Now you can use the wheel. The wheel would work just fine. For any letter headed with M, I go to an A to M wheel. I put plain text A on ciphertext M, and then find L on that wheel, and see what that ciphertext becomes. But if I use the square, which I really do like it, and I think I have plain text on the top, I want to talk about how to encrypt and decrypt. So first I'm going to talk about encrypting. And I'm going to call along this side, I'm going to call this my classes. Okay. And so for the first letter here, I'm dealing with the M class, and I'm trying to find the plain text L. And I'm trying to see where the M and the L meet. That gives me a ciphertext letter that will go in this spot. Okay. Then I move on and I use my A class, and I'm trying to encrypt an E. And so I want to find where A and E meet in the middle of the square. Okay. Now that is different than decryption. Let's talk about how to decrypt. Try to give myself a little more room here. So again, I've got plain text on the top and classes along the side. I only bring it up this way because this seemed to make the most sense for me when I was learning this. It was another version of it being said kind of the same way that helped me out. So I'm dealing with the class M, and for decryption, I want to find where M has Q in the middle. And I want to track that up to what the plain text letter is. Okay, so I start with my class M. I find my ciphertext, in that class M, and see what plain text that becomes. Similar on the second one, I'm going to start with my class A, go until I find my ciphertext, my letter U in there, and see what plain text that gives me on the top. Okay, that one may not be that difficult, but it still does take a little bit of work to make sure that we get it right. And then the only difference in the bottom is that I just have a different keyword for you, and I have a little longer statement for you to decrypt. But go ahead and give that a shot, and let's see how you do. Pause the video now, come back when you're done. Hopefully you had a chance to get through those. Let's see how you did. Leonard gets encrypted as XEHUTAKK. And again, that's kind of the weird thing about Vigenere ciphers is I have 2 Ks that are right next to each other that represent different plain text letters, and that's okay. That's something that happens in Vigenere ciphers. For the decryption, it becomes Euler. It's pronounced Euler. It looks like Euler, but it is Euler. Leonard Euler was a famous mathematician. He's got a number named after him, kind of like pi. For the decryption down below, the palindromes, it's ironic that I use the keyword palindromes in this multi-word palindrome. A man, a plan, a canal, Panama. It spells the same thing forwards and backwards, excluding spaces. So kind of a cool one if you ever want to impress your friends, if your friends get impressed by things like that. But yeah, so that'll be it for today. Hopefully you got a little bit out of it, had a quick snapshot at all of the ciphers that we used. If you have any questions, please don't hesitate to send me an email. Or, another thing you could do is, if Vigenere ciphers were one that gave you some troubles, throw a couple question marks by that and, highlight it somehow and bring it up to me on Wednesday when we meet again. I will be more than willing to sit down and help you through any single cipher that you have a hard time with. Other than that, I do have some videos up on the Google Classroom. Go back and look at the notes days, at the posts that I put the note sheet on there. By now, I should have attached some videos to those days as well. If you want to get a little more in-depth look on those, when we covered those different things. You are going to have to do a little bit of work. I might have put it in the title of the videos, but I don't remember. So just give it a look. Okay, do some work. You can look some things up, but like I said, sometimes they're a little bit, Wikipedia is not always the best source, but there are some out there that can definitely help you out. But again, don't hesitate to send me an email or just write down that you have questions on some of those, and I'll be more than willing to help you out. Anyways, I hope you have a great day, and we will see you next time.